In this video, we will talk a bit about how lenses work. This is the first of 3 videos about lenses. I'd like to start out with this little video that I made at home with a magnifying glass. And what I'm trying to show you here is that what we call a magnifying glass is also a projector lens. They're the same device. You change what you call it depending on how you are using it. So that's just a projection of the people who live across the street. And I'm bringing it into and out of focus on the back of my iPad as a little projector screen. Okay, for our conversations, we will be talking about 2 different types of lens. A lens of any type is a transparent object that alters the path of light rays in order to form an image. It does this by using refraction. A lens may be concave on both sides or convex on both sides. Those are the types we will be talking about. There are other types of lenses, and I'll show you that on the next slide. But as it says on the bottom here, if a lens is convex on both sides, it causes parallel rays of light that are entering it to exit on the other side in a way that allows them to converge. This is called a converging lens. If a lens is concave on both sides, then light rays that enter the lens parallel to one another will diverge as they leave the other side. So this is called a diverging lens. Really, any lens that is thicker in the middle than it is on the edges is a converging lens, and any lens that is thinner in the middle than it is on the ends is a diverging lens. But for us, we will stick with just talking about the 2 types of lens that are on the far left on this screen, the biconvex and biconcave, which I will refer to as converging lenses and diverging lenses. I will encourage you to consider not referring to these as concave and convex lenses because there are 2 sides to it and both sides of the lens are not necessarily the same curvature. A converging lens can either magnify or invert an image depending on the distances involved, and a diverging lens cannot invert. It demagnifies, but it also makes it seem like the object is a little bit closer than it actually is. It looks shrunken and closer. The diverging lens is what you see on the bottom right of this screen here. For both types of lens, we want to make sure that we are understanding a couple of key terms here. Let's start with this converging lens over here. As these light rays come into the lens parallel to one another, meaning that they are coming from very far away, basically. As they come in, they encounter the lens and are refracted by it, and because it's a converging lens, they converge. The point where they converge is called the focal point. For a diverging lens, as these light rays come in from the left, they are refracted by the lens in such a way that they diverge, meaning they will never intersect one another. But if you trace them backwards, these dotted lines here show that they seem to have all come from the same place. That same place that they seem to have come from is the focal point of a diverging lens. So for a converging lens, the rays actually do pass through a focal point. For a diverging lens, they seem to have come from this focal point, even though they didn't actually pass through that point. In both cases, the distance from the lens vertical axis, meaning the dashed line that's running down the length of the lens vertically, the distance from that dashed line to the focal point F is called the focal length of the lens, and that's often represented by a lowercase f. That lowercase f, the focal length, will be used in several different equations, the first and easiest of which is the lens power. Lens power is 1 over the focal length. Its units are called diopters. The more diopters your lens has, the stronger the lens is, either as a converging or diverging lens. Now I do want to note that as light rays enter a lens, they refract as they enter, and then they also refract as they leave. We don't really want to do the calculation of refraction both times as it enters and leaves a lens, so we will learn some simplifications for that in the next 2 videos, and we'll learn a little bit more complex use of the focal length besides just calculating the power of the lens.